Hello everybody, welcome back to channel B98.5. Today, we're going to be debating the pros and cons of certain GMOs. For those who don't know, GMO stands for Genetically Modified Organism. For decades, scientists have been genetically modifying organisms for a variety of purposes, whether it's to make certain organisms more resilient to harsh weather, or just make them grow more robustly. These GMOs have been heavily debated though, with some people supporting them for their groundbreaking solutions and efficiency, and others condemning them for cost along with understudied side effects and questionable ethical implications. Now that you're all caught up, let's get started.
Our first topic is golden rice. To begin with, normal, non-GMO rice is very poor in nutritional value. This in turn leads to high rates of vitamin A deficiency in populations where their main source of food is rice. A solution to this problem was the development of golden rice, a GMO rice strain. It was modified to produce beta-carotene, a necessary part of creating vitamin A in the body. It has also had the side effect of making this rice a yellow color, hence the name. This makes it distinguishable from natural, non-GMO rice. It grows the same way that regular rice does, so it's inexpensive in comparison to regular rice.
As said before, golden rice is a genetically modified strain of rice that was modified to produce beta-carotene, which is essential for vitamin A production in the body. This offers a potentially sustainable and long-term solution for areas of high rates of vitamin A deficiency. Another one of its benefits is that it requires no special steps to grow the rice, so the rice comes at no extra cost to the producer or the consumer. Many countries, such as the United States and Canada, have also conducted assessments that confirmed its safety for consumption. Genetically modifying rice could also have some indirect benefits, such as higher resistance to pests and other environmental stresses, leading to a higher crop yield and overall more food for everybody. In the end, golden rice is a cost-effective way to provide extra nutrients for areas where rice is a staple food and vitamin A containing foods are abundant.
While golden rice may be useful, it is not without its drawbacks. GMOs like golden rice are extremely controversial and opposed in some parts of the world. Individuals should not be concerned about the safety of GMOs for human consumption or the environment because there is a general consensus among scientists that the large majority of them are perfectly fine. This is a far-fetched criticism since golden rice and other GMOs have already been proven to be safe for human consumption. Second, critics worry that genetically modified rice species will spill over into wild rice species and contaminate natural ecosystems, and that herbicide-resistant weeds will evolve if golden rice is genetically altered to have that characteristic. Additionally, the process of securing regulatory approval for GMO crops such as golden rice is slow and expensive, which delays its delivery to vulnerable people who need it the most. Golden rice predominantly addresses vitamin A deficiency and does not eliminate other pathways to malnutrition, such as deficiencies in other vitamins. A diversified diet is still essential to good health. Others have attacked the earlier iterations of golden rice for lacking enough beta-carotene content to have a large impact on vitamin A deficiency. Recent generations of golden rice have been retooled to contain more beta-carotene, however. In summary, golden rice is not without its weaknesses, some of which could possibly be corrected by redesigning this GMO to possess more desirable characteristics. Insulin is a naturally occurring hormone produced by the pancreas in many species and which regulates the blood sugar level by assisting cells in using glucose for energy. It helps the body use carbohydrates, proteins, and fats for energy and stores excess glucose for later use. Insulin helps maintain steady blood sugar levels and is widely used to treat diabetes. It can be taken from horses and cows to be given to people who are diabetic, but it is dangerous since it could transmit diseases. To avoid using this possibly dangerous animal insulin, scientists developed a genetically modified bacteria that releases insulin. It is made from E. coli, and the procedure is to introduce the human insulin gene into it, whereupon it begins to produce the protein as though it were its own. The method provides a feasible and mass-producing way of deriving human insulin and has therefore become the new primary source for the treatment of diabetics.
What are the advantages of insulin-producing bacteria? These genetically engineered bacteria can boost large amounts of human insulin very fast and cheaply in comparison to regular animal insulin. These organisms have greatly increased the supply of insulin globally, giving more people with diabetes access to insulin. There's no difference between human insulin and the insulin that's produced by these bacteria. This means that there is a very low chance of allergic reaction or immune response, such as those common in insulin from animals. Using bacteria raises less ethical concerns than animal-derived insulin. It can also be used by people with dietary and religious restrictions. This insulin created by these bacteria is oftentimes purer and more consistent in its quality than animal-derived products, but not using animals, the risk of transmitting an animal disease is eliminated. There are many more advantages to insulin-producing bacteria, but these are the highlighted ones.
Although insulin-producing bacteria can prove to be useful, they aren't exactly the perfect solution either. As previously stated, the insulin-producing bacteria is a genetically modified organism, or GMO. Its genes are designed to make it produce insulin similar to that of a human to minimize health risks. However, while the insulin is similar to the human-made stuff, it's not completely identical. The small structural differences can precipitate unexpected responses from the human body. Within the insulin production process, there are also other flaws which need to be acknowledged, such as the purification process. The process may be effective, but it's clearly not effective enough, as trace amounts of E. coli byproducts are often found in the insulin even after the purification. This may pose health risks for some certain individuals. Other than the insulin itself, there are also outside problems that need to be acknowledged, such as the high cost and time-consuming process to set up such facilities, along with the lack of global accessibility and ethical implications of forcing bacteria to produce human insulin.
And that's it for today. Thank you for tuning in to today's debate on the possible advantages and disadvantages of certain GMOs, or genetically modified organisms. Now that you've heard some possible effects of these GMOs in our daily lives, we hope we've expanded your knowledge and understanding on this issue.